Thanks for joining us today for this BlastLogic webinar. Electronic timing tools were added to BlastLogic in version 2.1. Today, Specialist Mining Engineer Roxana Gianazza will outline key features of BlastLogic electronic tie-ups and how to use these tools to support complex blasting. If you have any questions during the session, please add them to the questions panel on the GoToWebinar interface. We will try to address them all at the end of the presentation. Over to you, Roxana.
Thanks, John, and good morning, everyone, and thank you for joining us. My name is Roxana, and as John mentioned, I'm a mining engineer with Maptek and have been involved with BlastLogic team for almost 4 years. My role includes new customer implementation, both in Australia and overseas, support, training, and development of new features. Prior to this, I was a drill and blast engineer for mines in Queensland and New South Wales. As a very brief introduction, BlastLogic is a design and reconciliation tool that allows engineers to take a blast from the design stage to fire. Today, I would like to showcase some of the advanced electronic timing features in BlastLogic, using two complex tie-up examples. Firstly, I will run through a through-seam scenario using horizons to assign timing to a different section of the hull. The second will be a two-deck blast scenario with all-west separation. I will attempt to complete the entire process from creating a new plan, adjust timing and modeling, and finally exporting and printing. I'm now going to switch to the desktop application. So this is a live software demonstration. What you're seeing now is the desktop for BlastLogic. This is the tool that drill and blast engineers use on a daily basis. I have my two imported blasts on the top left here. And I'm going to bring the first one on the screen, so the through seam. And then I'm going to swap to profile view to show you what I've attempted to do with the intervals. So if you haven't used intervals before, it's just a way of assigning a section to a blast by using a top and bottom surface. This could be DXFs, but also grids or triangulations. In this example here, you can see that I have two cold seams intersecting my hulls, and then the hull is separated by overburden, interburden, and underburden. If I swap to the charge plant scenario, you can see that the hulls have been loaded accordingly. So I got my stemming. The red sections is the explosive decks. So in this particular scene, particular hulls, I got 3 separate explosive decks, and each of them have a primer. So these little circle puddles are actually the primer positions in the hull. And the first layer, like I said, is the overburden, and then interburden deck, and then the underburden. Next, I'm going to create a tie-up and assign a different interval for each of these sections. I'm going to exit the profile view and create a new tie-up by right-clicking on the folder and new tie-up design. Okay, so now you can see my blast in plain view. This is a 3D model, but I can rotate and use plain view if I want to. On the right here, I got my 3 defined intervals, overburden, interburden, and underburden. If I click on Edit Horizons, it actually allows me to create as many intervals as I want, for example, test. And the next two options, it also allows me to define a difference in timing between multiple decks within the same interval or within detonators within a single deck. And then this option on the right is that I can select one or multiple intervals for each of those horizons. Okay, so the next step, I'm going to click on the overburden. So the overburden was the first section of the hulls. If I rotate it, you can see here on the left, there's a faint outline on the top section of this hull, so where the true seam is coming through. So by zooming on, I'm now going to be placing a timing rose, which will set the propagation rate. I'm going to start by placing the start point, and then the second click will actually allow me to define the orientation and the propagation rate. As you can see, all the hulls have been assigned, and now if I zoom in a bit further, you can see that there is now a time for each hull, and I can also edit this object by clicking on the vertices. So there's these little dots that I can drag out to change my propagation rate. And I can also use my circle to rotate. To view what I'm doing, I can bring in my timing contour plan. And select the horizon I'm working in. So in this case, overburden. And as you can see, this pop-up panel is actually adjusting as I'm making changes to my plan. So if I rotate my timing rows, you can see the timing contours are also updating. So this is live plan. Normally, if you do have two screens, I put my model on the left, and as I'm making my changes, I can also see what is coming up on the screen. All right. So now I'm going to click on the interburden layer, the second one, and I'm going to add a timing line. The timing line is for my multiple segments, each with their own propagation rate. So I'm going to create a timing line from this side and click for the first segment, second segment, and I click to finish. As you can see now, I've got two lines, each with their own individual propagation rate. And again, I can adjust up and down the magnitude of these segments. If I swap to the second horizon, you can see this is the timing has been associated, and I can edit all these vertices or add new points in. So if I wanted to add a new segment, all I need to do is right-click, split, and now I've got more tools I can operate with. So I'm going to now quickly go to the underburden and just apply another timing line here to finish. Okay, cool. So now I already have the entire blast with timings associated for each horizons, and I'm going to run an animation to view what I've actually done. So I'm going to use blast modeling, animation tie-up, and click play. So as you can see, this is actually a 3D model, and because the left section of my blast has got two cold streams coming through, they're actually detonating in different times. I'm just going to run that again. So this is the first underburden, and then the underburden coming off, and then the overburden. And then on the right section of the blast, there is no, there are no seams cutting through. Okay. So at this point, I haven't actually wired or sequenced my holes, but I can already export my initiation times by using to a CSV by right-clicking on my draft and going export initiation times. And this basically will give me a CSV of my hole IDs with X, Y, X coordinates and the timing for each hole. All right, so now let's go to the second blast, the B one. So we're going to close this panel. And I'm going to create a new tie-up. Again, I'm just going to right-click on the tab folder, go new tab design. I'm going to rotate. And I'm going to bring in some polygons to define the O-West positions. So these ones are just polygons that can be created in BlastLogic, or they can be imported from an external package as DXFs or as polygons, basically. So these two yellow areas define the west positions in this blast. So what I'm going to do now, I'm going to place a center lift starting from the right by using timing rows. I'm going to start from the center here. That. I'm going to bring up again my timing contour map. And now I'm going to select the last two rows and assign an offset to protect the wall. So you can see I've got my hole selected, and then on the right there is this plus and minuses that I can use to change the timing. So I'm going to add 200 milliseconds and click on plus, and then select just the back row and repeat that. and turn it again. So if I zoom in, you can see now those holes have got a plus 200 milliseconds delay from the original timing, and then the last row has got 400 plus. Now, because I also got some waste here, I'm going to create a second initiation object to this section of the blast, and then separate the blast by which area I wanted to initiate first. So I'm going to create the timing line, starting from here. Click OK. And then I'm going to select the first left half of the blast and associate it to my new object. So right click and associate, and it's done. So I don't know if you can see now in the timing contours, I've got one section of the blast coming off timing from the left, and one section actually associated to the center lift on the right. I actually prefer to use timing objects for electronic timings, simply because if I start with design hole positions, they will automatically update as the ruled or survey data is entered. So you don't have to redo your plan if you got the actual position, you just have to update the hole position in the plan. If I wanted to use hole-by-hole connections, I can still do that by opening up this delay panel, tapping in a couple of electronic custom delays I like to use, for example, 108, 45, and 2. And then I'm going to actually swap. So these holes are currently in the drilled locations. I'm going to swap the design as designed, so that the lines are a little bit straighter and easier to type together. And then using this row tool, I'm going to select my first hole. And connected. So as you can see there, this is very similar to what is normally used in now when I'm connecting hole by hole by using 108 custom electronic timing that I just added. You can have you can separate your blast whatever you want, and we also support hybrid blast by using a combination of non-L systems and electronics. So the next step, I'm going to remove my additional horizons and optimize by the number of detonation counts. I'm going to remove these that are no longer used. Okay, and then I'm going to click on my open up my timing envelope. So a timing envelope gives me the number of detonations within a particular timing interval. So on the top right is now set on 8 milliseconds, but if I want to, I can change it to 5 milliseconds or whatever number you would like to put in. So in a 5 milliseconds time window, I can see that my maximum number of detonations is actually 10 here on the scale on the left. So by using the optimize, I'm going to try to reduce that to 1 or 2 detonations. So I'm going to click on optimize. It's just will automatically attempt to offset the time up or down by maintaining the timing lines. So I'm going to click optimize. Yeah, so now you can see that in most cases, I was able to reduce the number of detonations to 2. And of course, at the top here, where I used my electronic custom hole-by-hole delays, I have to maintain the 4 detonations. Okay, so next step, I'm actually going to edit. I'm actually going to go and edit the label positions. So to do that, I'm going to click on labels. And I'm going to change the orientations of my hole LEDs to 75 degrees. So I can do this for the entire blast or for just a selection of holes. In this case, I'm going to select all the holes and go orientation 75. That. And if I want to, I can also just select the fine holes, like for example, just these 2 here, and change it to the horizons. And I'm going to display the initiation times a bit smaller, bigger. So just an example what you can do. Obviously, the way you display your labels in this stage will also come through your printable sheets. To create a tie-up sheet, you can right-click on your draft name and go into Design Typesheet. And basically, this is some templates where you can create printable PDFs to give to the shop file. This is very easy to use. You just rotate the blast however you want to print it, and then create a new page. I can now use these vertices to adjust the size of my page or rotate it. And then I can display what I would like to see on my first page. So in this case, I can say I want to see my all IDs initiation times. And then on the second page, I would like to see, for example, the timing contours. You can actually define the interval you would like to see the timing contours in, for example, 500 milliseconds. The other option is also to be able to display the burden relief. And basically, this creates a PDF that will open up straight away. So I'm just going to show you what it looks like. So this is the first page with the whole IDs. And this is the second page with the timing and the contour lines. Cool. So the last step in the process is to create my writing lines in my sequences. BlastLogic can support multiple systems. So to give you an example of what system we currently support, I'm going to go into the Blast catalog, File, Setup, Blast product catalog. We do update new systems as they come online. So scrolling down, I'm going to go to the Electronic Initiation System tab and add New Electronic System. And as you can see now, I can use the drop-down to select from existing system available. We have Conti, David Bickford, .NET, Systems, Orica, and Access. And within the system, obviously, there are some customization in place as well. So if I, for example, select Orica, I can also choose what type of detonator I want to use between, for example, Icon or Icon 2 and 3, the logger type, and the blaster type. And for each of these values, I can then use the pre-populated fields or add my own fields for what the system requirements are. These will be hard limits that will be flat once you do the export format. Okay, so to wire this particular blast, I'm going to now click on the Wire tab here and select the initiation system I want to use. So in this case, it will be Icon. And I'm going to use the same row by hole tool that I used before. Let me just open up again. And Wire Icon. And I'm going to start from the top here and just draw my first path. Like that. And as you can see, I don't know if you can quite see, there is a label next to my arrow that's actually giving me the number of debts that are currently connected together. Just continue like that. If I wanted to, I can also expand my search radius and connect holes on both sides of my mouse. So if I go, for example, for a 10-meter search radius, and I start from this side, from the left, going to the right. I don't know if you can quite see, but So you can do all fancy stuff by using the search result to connect multiple holes. Once I'm happy with the parts I've created, I can now do an export. But let me just do another row first, and then I'm going to swap to one that I already tied up. Okay, so let's go to completed one. So this is very similar to what I've currently done, but I actually completed the drafting sequence. So you can see on the wire, I got my holes now connected in sequence. Every sequence got a different color. If I wanted to, I can at any point change either the blaster name or logger simply by tapping here. So if I want to go, for example, 1, 2, no, say 3 and 1, it will change my sequence for me. That. Same with the blasters. And now I can go export, which is this button on the bottom right. And if I've selected a particular initiation system, it will allow me to export in the format for that system. So if I click on the drop-down menu, see at the moment I've got the option to either use a PDF to export my sequences or the particular Shot Plus icon export for this particular system. You can export all of the sequences or one by one. Cool, and I think that's pretty much it for completing the process from start to finish. If you have any questions, please let me know. Otherwise, I'm going to now return to the slides.
Thanks so much, Roxana, for running through BlastLogic electronic type tools. We have got a question for you. If the shot firer has placed an additional primer into a hole, how can I change my timing plan to account for it?
Okay, so we actually have an option called low primers in BlastLogic. So I'm just going to turn back to the desktop. So I haven't showed this before, but I can actually display the timing for each of the detonators in the hole. So if I click on the display up here, I can sweep to all detonators initiation times. And you can see I currently have 3 det per hole. But let's say I select the back 3 rows, the back 3 holes, and go into Edit, Low Primers. I can select to either add or remove particular primers to a hole. So let's say I wanted to add a new primer. The selection for the crew and shot fire is actually optional, but I can select either my top or bottom deck. Say I'll do the bottom deck, the position of the det down the hole, and then the product. So let's say I want to use a 30-meter lead length line and my booster. And then from the bottom, so 1 meter or half a meter, like that, and got our primers. And I can see straight away on my screen, and I'll go 4 dets. On top of this, if my horizons have assigned interval between the holes, let's say I'm going to now put a 5 millisecond delay between detonators and 100 milliseconds delay between decks. Like that. Give it a second to update. I don't know if you can see the changes, but now all these detonators were originally firing at the same time. I now got a 100 millisecond difference between the top and the bottom, and also got a 5 millisecond difference between the bottom and the top detonator for each of the decks. So to show you what the decks look like as well, you can see the position of the primers down the hole, and the top and bottom decks are in red. Cool. That's it.
Great. Thanks again, Roxana, for the showcase of BlastLogic's electronic tie-up features. If anyone has any further questions, please contact the BlastLogic team or your local Maptek office for assistance. You can find all the relevant contact details on our website. If you'd like to view this webinar again or share it with your colleagues, it's available online at maptek.com. While you're there, you can catch up on our other webinars covering a whole range of topics. Stay tuned for additional webinars, including demonstrations about BlastLogic vibration modelling and its OData service. Thanks again for watching.